Well, thank you very much, Professor Keelkopf. It's very nice to be with you. Started out a little rainy yesterday, but it seems that the weather is cooperating. And about looking young, my children are working on correcting that. And I'm aging rapidly as they enter their teenage years. Okay, since we don't have much time, I think what I would like to do is go straight to the basic question here that we want to talk about today. That is the basic question, of course, isn't it? Well, it turns out this is a basic question, although you might not think of it right away. This is chemical reaction. Ammonium cyanate gives urea upon heating. And in 1828, a German chemist by the name of Friedrich Wöhler was the first person to conduct this reaction. He heated up ammonium cyanate, and he was really surprised to see that urea was produced. Now, why was he surprised? Well, it turns out that urea, or that ammonium cyanate, is an inorganic material, something that's not found in living systems. But urea was known to be a biological waste product. And this was the first demonstration that something non-living could give rise to something from life. And it shattered the distinction between living and non-living that was supposed to exist up until that time. And more than that, it's opened up for scientific study all of life. If living things are made up of ordinary matter, like rocks and such, then science can study them. And in the intervening 170 some odd years, science has learned a lot about life. We've learned the structure of DNA and cracked the genetic code and learned how to clone genes and cells and even whole organisms. But what has our knowledge really told us about life and the universe at large? Well, there's a number of opinions on that, but I think they can kind of be boiled down to two different categories, two different poles. And perhaps the first side can be represented by Richard Dawkins, who is a professor of biology at Oxford University. And Dawkins has written that the universe we observe has precisely the properties we should expect if there is at bottom no design, no purpose, no evil and no good, nothing but pointless indifference. I hear he's a lot of fun at parties. The second point of view can perhaps be represented by Cardinal Joseph Ratzinger, who's an advisor to Pope John Paul. And about 10 years ago, he wrote a little book entitled In the Beginning, A Catholic Understanding of the Story of Creation and the Fall. And in his book, Ratzinger wrote the following. He said, "Let us go directly to the question of evolution and its mechanisms. Microbiology and biochemistry have brought revolutionary insights here. It is the affair of the natural sciences to explain how the tree of life in the particular continues to grow and how new branches shoot out from it. This is not a matter for faith. But we must have the audacity to say that the great projects of the living creation are not the products of chance and error. They point to a creating reason and show us a creating intelligence, and they do so more luminously and radiantly today than ever before." Well, let's stop a second and notice a couple of things about Ratzinger's argument. First thing is that, in distinction to Professor Dawkins, he says that the world does look like it has a purpose, like there was design in the world. And the second point is that in order to support this contention, he points to physical evidence. That is, to the great projects of the living creation, which point to a creating reason. Not to philosophical or theological or biblical arguments, but to physical evidence. And the third point is that, in particular, he points to the science of biochemistry, which studies, of course, the molecular basis of life, as having particular relevance to this question. And it's my intention in this time we have together to show you why I think that Ratzinger has the better of the argument, and why Professor Dawkins is perhaps whistling past the graveyard. Much of the discussion here, of course, started with the publication of The Origin of Species in 1859. And in The Origin, of course, Darwin proposed to explain something that nobody else had been able to explain before: how the great variety and diversity of the biological world might have been produced by a completely natural mechanism. And it was a very elegant theory he proposed, of course, the theory of natural selection working on random variation. In particular, Darwin said, well, in general, he said that there is variety in all species. Some members of a species are bigger, some faster, some lighter in color than others. And there is not enough food around for everybody who is born to go on and reproduce. So Darwin reasoned that those whose chance variation gave them an edge in the struggle to survive would in fact tend to survive and go on and leave offspring. And if the variation could be inherited, then the characteristics of the species would change over time. And maybe over great periods of time, great changes could occur. As I said, it was a very elegant theory, but biologists of the time were not sure that it could account for all of biological complexity. There were some biological organs and systems they pointed to which they did not think could be approached in Darwin's step-by-step gradualistic natural selection. And they talked about a number of things, but in particular, one they pointed to was the eye. And they knew that the eye consisted of a number of components. There's the retina and the lens and tear ducts and ocular muscles and so on. And they knew if an organism were born so unfortunate as to be missing one of these components, then the result would be severely diminished vision or even outright blindness. And so they wondered if Darwin's theory could account for something like that. Well, Darwin knew about the eye too, and he wrote about it in a section of The Origin appropriately entitled Organs of Extreme Perfection and Complication. And he said he didn't know how evolution might have produced the eye. But nonetheless, Darwin said if you look at eyes in modern organisms, you see a lot of variety. For example, some, not really eyes, but really spots in simple creatures can detect light. They consist of photosensitive cells, not much more than a light-sensitive spot. And light coming from this direction or this direction will stimulate the cell, so it can tell it can tell that it's in the presence of light or darkness, but it can't tell which direction the light is coming from, because light from any direction essentially stimulates it. But if you put the light-sensitive spot in a little cup, now light coming from one direction will illuminate one side of the retina, but leave the other one in shadow. And at least in theory then, the organism can tell which direction the light is coming from. And if you deepen the cup and you start to fill it with a gelatinous material, now you've got the beginnings of a crude lens. And using arguments like this, Darwin was able to convince many of his contemporaries that a gradual evolutionary pathway existed from something as simple as a light-sensitive spot to something as complex as the modern vertebrate eye. And if evolution could explain the eye, well, then what could it not explain? But there was a question left hanging by Darwin's explanation. Where did the light-sensitive spot come from? It seems like an odd starting point. Most things are not light-sensitive. Tablecloth is not light-sensitive. The floor is not light-sensitive. What does it take to make a light-sensitive spot? Well, again, Darwin didn't know, and this time he refused even to speculate about such a thing. He wrote in that same section of The Origin of a Species, "How a nerve comes to be sensitive to light hardly concerns us more than how life itself originated." Well, okay. Well, it turns out in the past few decades, science has become interested in both of these questions. What does it take to make a light-sensitive spot, and where did life come from? But Darwin was correct, I think, in refusing even to address this question, because the science of his era didn't have the tools even to begin to look at it. Just to give you a flavor of the times, in Darwin's day, atoms were theoretical entities. Nobody was sure that they existed. And the cell, which we know to be the basic unit of life, was thought to be a simple little piece of protoplasm, kind of like a microscopic piece of jello. And of course that has turned out not to be true too. So Darwin's age did not have the conceptual or the physical tools even to begin to answer such a question. So he left it uninvestigated in the hope that future scientists would be able to take a look at it and resolve it in favor of his theory. Well, in the intervening years since Darwin published, science has learned a lot about that question. So why don't we just take a minute or so to go back and address that question that Darwin was unable to answer and ask ourselves, what does it take to make a light-sensitive spot? What happens when a photon of light first impinges on your retina? When a photon of light first hits your retina, it interacts with a small organic molecule called 11-cis-retinal. And 11-cis-retinal is kind of a bent molecule, but when the photon hits it, it isomerizes into a linear shape. And that's kind of the switch that sets in motion a whole cascade of events, which are shown on the next transparency. Now, this is a little cartoon of the chemistry of vision, and one thing to say first off is that it's not to the same scale as the last slide. The retinal is bound to a protein rhodopsin, which is represented by this little oval here and labeled RH. The change in the shape of the retinal forces a change in the shape of the rhodopsin to which it's bound. When that happens, it exposes a binding site on the rhodopsin, allowing it to interact with another protein called transducin. The transducin had bound a molecule called GDP, but when the rhodopsin interacts with it, the GDP falls off and a molecule of GTP attaches itself. Now the rhodopsin-transducin GTP complex interacts with an enzyme called phosphodiesterase. When that happens, the phosphodiesterase is switched on and acquires the ability to chemically cut a small molecule called cyclic GMP, turning it into 5' GMP. Now there's a lot of cyclic G in the cell, and when the phosphodiesterase starts to cut it, its concentration goes down. Some of the cyclic G had bound to a protein over here called an ion channel, which normally allows sodium ions into the cell. But when the cyclic G concentration goes down, the one attached to the ion channel falls off, and the shape of the ion channel changes and closes down. Now sodium ions can't get into the cell any longer. That changes the voltage across the cell membrane, which eventually causes an electric current to be sent down the optic nerve to the brain. And when interpreted by the brain, that is vision. So this is Darwin's simple light-sensitive spot. And although it looks complex, I should tell you that this is really a cartoon overview of the chemistry of vision, and we haven't talked about a lot of necessary things necessary for this to work, like how does the system recover and get set for the next photon. But nonetheless, I think this is enough to show you that what Darwin and his contemporaries took to be simple starting points have turned out to be enormously complex. Much, much more complex than anybody had ever dreamed. Well, okay, it's complex. The question is, can it be explained by Darwin's theory? And it turns out that Darwin himself gave us criterion by which to judge his theory. Darwin wrote in The Origin that if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. Here Darwin was emphasizing that his was a gradual theory. Slowly, things would improve very, very slowly. He knew that if things improved rapidly or in big jumps, then it would begin to look suspiciously like something else. Well, what kind of an organ or what kind of a biological system or cellular system or biochemical system could not be formed by numerous successive slight modifications? Well, at least for starters, one which is irreducibly complex or has the property of irreducible complexity. Irreducible complexity is a fancy phrase. I made it up to make people think I'm smart. But it actually stands for a very simple concept. It just means you've got a machine or system or something that has a number of different components, number of different parts, and the parts interact with each other to produce a function that none of the parts by itself could produce. And just as an illustration, we can look at an example of irreducible complexity from everyday life. This is a mousetrap. Now, a mousetrap has a number of components. It's got the wooden platform to which everything else is attached. It's got this tightly wound spring with extended ends to press against the platform and to press against this metal piece called the hammer, which actually squashes the mouse. And when you push the hammer over, you've got to stabilize it in that position until the mouse comes along, and that's the job of something called the holding bar. And the holding bar at the end of that has to be inserted into the catch to stabilize it. Now, the mousetrap needs all of these components to work. If you take away the holding bar, if you take away the spring, or you take away the platform, you don't have a mousetrap that works half as well as it used to, or as quarter as well as it used to. You've got a broken trap. It turns out that, so essentially the mousetrap is irreducibly complex. It turns out that things like this are big headaches for Darwinian theory, because natural selection needs a function to select. Recall that Darwin, in explaining the eye, started with a light-sensitive spot. He started with something that was doing something and then tried to improve it gradually. But if you were going to try to build a mousetrap, what would you start with? Would you start with the platform and hope to catch mice kind of inefficiently, and then add, say, the holding bar and hope to improve the efficiency? No, of course you can't do things like that, because the function of an irreducibly complex system really only appears at the very end, when all the components are together. Well, mousetraps are very interesting, of course, but the question we really want to address is, are there any irreducibly complex biological systems or cellular systems? And it turns out that yes, there are tons of them. Because of the time we have available, I'll only cite one today, but it's a very interesting one. And this is called the bacterial flagellum. This is a drawing of the flagellum taken from a popular biochemistry textbook by Vogt and Voet. And the flagellum is quite literally an outboard motor that bacteria use to swim. And as you can see, it's got a number of parts. This part here is the part that does the job of the propeller, contacting the water and pushing against it as the whole thing rotates in order to propel the bacterium forward. The propeller is attached to the drive shaft by something called the hook, which is made up imaginatively of hook protein. The hook acts as a universal joint, allowing freedom of rotation around here and around here. The drive shaft is attached to the motor, which uses a flat flow of acid from the inside to the outside of the cell to power the turning. Now, just as an outboard motor has to be attached to the boat and kept stationary while the propeller turns, the flagellum has to stay stationary within the plane of the membrane, and that's the job of components called the stator. And these rings of proteins do that job. And the drive shaft pokes up through the bacterial membrane, and there are some proteins that act as bushing material to allow that to occur. And although this looks complicated, it really doesn't tell you the whole story. And thorough genetic studies have shown that about 40 different proteins are generally involved in a flagellum, either as components of the flagellum itself or as parts of the system that puts this together within the cell. Now, it turns out that the flagellum is irreducibly complex. If it weren't for the propeller, if it weren't for the hook, if it weren't for the drive shaft, if it weren't for a number of those 40 different components, you would not get a flagellum which spun half as fast as it used to, or a quarter as fast as it used to. You would either, not get one made at all, or you would get one that simply didn't work. So like the mousetrap, it needs a number of different parts to do its job. And like that is a very big conundrum for Darwinian theory. Up until this point in my talk, my criticisms of Darwinian theory are not really new. a number of scientists have looked at systems like the flagellum and other ones I talk about in the book, and have questioned whether a gradualistic approach like Darwin's could produce them. You know, folks like Stuart Kaufman at the University of Pennsylvania, and Lynn Margulis at the University of Massachusetts, James Shapiro at Chicago, and so on. A number of people have questioned whether Darwinian theory can account for such complex molecular systems. Where I differ from those other critics of Darwinism, however, is in the alternative I've proposed for how those systems got there. And I've written that if you look at things like the flagellum or the cilium or the blood clotting system or the intracellular transport system and so on, if you look at them, they look like they were designed. They look like they were purposely designed by an intelligent agent. And that has attracted some attention. And some of my critics, and you should be aware that I do have a couple critics, not everybody, most people, not everybody agrees. My critics have said that this Behe fellow is a known Christian, and he's been seen entering and leaving churches. And therefore, this idea of intelligent design is a religious idea. It's nice, but it's not science, and I'm letting my religious beliefs interfere with my scientific work. Well, I appreciate their concern, but I think the idea of intelligent design is a completely empirical one. That is, it's based wholly on the physical evidence, along with a realization of how we come to a conclusion of design. How do we decide that things were designed? Every day we walk down the street, we decide that some things were arranged, other things not arranged on purpose. How do we do that? Well, in order to illustrate how we come to a conclusion of design, let's take a look at the following. Here's I don't know if you can see it, here's a Far Side cartoon. And we've got a troop of jungle explorers here, and the lead explorer has been strung up and skewered. And this fellow turns to this guy and says, "That's why I never walk in front." Words to live by. Now, if you can see it, anybody who sees it quickly realizes that this was designed. It wasn't an accident. His death was intended. How do you know that? Is it a religious conclusion? Probably not. Well, it turns out that you know this is designed because you see a number of different parts interacting with each other to produce a result which none of the parts by themselves could produce. Essentially, you see irreducible complexity. Now, there's a lot more that could be said about design, but we don't have time to address that today. But one thing I should say is that this is really not a difficult concept to grasp. If you can illustrate your main point with a Far Side cartoon, we're not talking quantum physics here. Nonetheless, the book, Darwin's Black Box, in which I've written about this and made this argument, seems to have caught a lot of people by surprise. And because of that, it's gotten a fair amount of attention and has been pretty widely reviewed. You know, the New York Times, the Washington Post, the Allentown Morning Call, all of the major media. It's my hometown. And Christianity Today and Skeptic magazine. So people with a lot of different viewpoints have looked at these arguments I've advanced. And among these reviews have been a number by scientists, by evolutionary biologists and biochemists and so on. What have they had to say about the arguments I make here? Well, they've certainly said a lot of things, but one thing that most everybody agrees on is that the systems that I talked about in the book are very, very complex and unexplained, currently unexplained. For example, in the New York Times, James Shreve, who's a science writer, has written that Mr. Behe may be right that given our current state of knowledge, good old Darwinian evolution cannot explain the origin of blood clotting or cellular transport. And James Shapiro in National Review, Shapiro is a professor of biochemistry at the University of Chicago, writes, there are no detailed Darwinian accounts for the evolution of any fundamental biochemical or cellular system, only a variety of wishful speculations. And in Nature, Jerry Coyne, who's a professor of evolutionary biology at the University of Chicago, writes, there is no doubt that the pathways described by Behe are dauntingly complex, and their evolution will be hard to unravel. We may forever be unable to envisage the first proto-pathways. And that's my favorite one. Can you see it? Let me put it back. Somebody liked it. But nonetheless, of those reviewers that I showed you, none of them actually thought that design was a good scientific idea. Now, why is that? Hopefully, when you saw that picture of the bacterial flagellum, the idea of design jumps right out at you. It looks designed. Why is design not a good hypothesis to investigate? Well, let's look at some of the comments of the reviewers to see why. James Shreve writes, shouldn't we leave something for our children and grandchildren to puzzle out, besides which systems in the cell are intelligently designed and which are not? And James Shapiro writes, sadly, despite his valuable critique of an all too often unchallenged orthodoxy, Darwin's black box fails to capture the true excitement of contemporary biology because it is fighting the battles of the past rather than seeing the vision of the future. Man's got a career in politics ahead of him, I think. And in Nature, Jerry Coyne writes, it is not valid, however, to assume that because one man cannot imagine such pathways, they could not have existed. Kind of missing the point that it's the entire scientific community that has failed to imagine such pathways, and not just myself. So perhaps you can see from these quotations why I think that these are not really compelling scientific reasons for not entertaining an idea of design. They seem to be more philosophical or even aesthetic. And why should that be? Why do scientists not like an idea of design? Well, the short answer is I don't know, but I think that at least part of the answer has to do with the following, and that is that they think that a theory of intelligent design points strongly to something beyond nature, that it has very palpable philosophical and theological implications, and some of them are uncomfortable with that. Some, frankly, because they are uncomfortable with religion in general, but others because they don't think religion and science should mix, and that something with such strong implications should be avoided. I disagree with them. I think that a scientific theory can have strong theological implications, but nonetheless be a very good scientific theory and be strongly grounded in the physical evidence. And as a matter of fact, we have an example of that already in the Big Bang theory. The Big Bang has struck many people as having theological implications, and many of those people didn't like those implications, but saw them nonetheless. But even though the Big Bang had such implications, no one will deny that it's been a very fruitful scientific theory. An additional point is that other areas of science in the past decades have started to point in the same direction as intelligent design in biochemistry. That is, that they seem to be pointing in the direction that something outside of nature is needed to explain the universe and life. And I don't have time to go into it, but just let me list them. The fact that the universe has an origin, the fact of things called anthropic coincidences, which is the label that physicists put on those features of the universe which look suspiciously fine-tuned to allow for life. and the intractability of the question of the origin of life. All of these things have struck other people as pointing to the need for something beyond matter and energy, design or information, or call it what you will, but something else to explain the world we live in. And considered in this context, the idea of intelligent design in biochemical systems is not that surprising. It seems to point in the same direction. And when different areas of science point in the same direction, it makes you optimistic that you're onto the right track. So in conclusion, I'd just like to refer back to the quotations with which I began this talk from Richard Dawkins and Cardinal Ratzinger, and say that I hope you can see why I think that, in fact, Ratzinger does have the better of the argument, and that the untold story of late 20th century science is how much different areas are pointing to the idea of design. And with that, I'd like to thank you for your attention.
We have time for some questions, Mike, if you'd like to entertain you.
Okay, I'd be glad to.
Does
Yes.
punctuated evolution play a role in this discussion?
And repeat the question.
Okay, the question is, does punctuated evolution or punctuated equilibrium play a role in this? And that's a good question. Punctuated equilibrium is an idea put forward by Stephen Jay Gould and Niles Eldredge, who are paleontologists. And they noticed that if you look at the fossil record, it did not fit Darwinian expectations. That the general pattern in any particular line is no change for a long period of time, followed by pretty rapid or large changes over brief geological time periods. And I think that the important point to realize about that is that punctuated equilibrium is not an explanation. It's just a label. It's essentially, equilibrium says things don't change for a while. And punctuation says sometimes they change quickly. And so it's a description of what people find. It's not a mechanism for how these things do change. So it's a useful concept to keep in your mind, but it doesn't explain where things came from.
Those responses of the people to your book that you put up there, those were sort of a classic response that someone that has a modernistic philosophical base would answer to, especially the idea that, well, you're just fighting old battles in the past. Because if you really look at modernism, it was the idea of throwing off the past using scientific inquiry to figure out everything. You know, and you can sort of think that, or you can sort of observe that in general modernity, as people call it, that ethos, that way of thinking, is beginning to unravel. At least there's people that are saying that quite a bit. And you know, you could also argue that there's we're going through a transition philosophically, I think, in educated fields. I mean, it's really striking to look at those arguments and see they're not refuting your evidence; they're refuting your philosophical approach. And I guess that's much I'm asking the question: is that do you agree with what I just said?
Well, if I understand it correctly, I think I do agree with the thrust of it. Yeah, the basic response to my book has been philosophical, either philosophical or kind of delaying tactics. Say, either science cannot conclude design, or can't deal with the supernatural, or some variation of that, or give us another 10 years or 20 years, and then we'll come up with the answers to these questions. Philosophical considerations have played pretty heavily in the responses to the book, and most everybody has philosophical presuppositions, but many people, including many scientists, don't realize that they do, and that's a bad situation to be in. Actually, I think that a Christian or a theist in general is in a better position to evaluate the evidence in this area than a person who is a non-theist or a materialist. Because, at least for myself, I would be very happy thinking that God designed life through an evolutionary process. If God wanted to set up natural laws to produce life by secondary causes, who am I to tell him what to do? Or I can think that perhaps God did things more directly, or added more information, or somehow did something a little other than just use secondary causes. Now a materialist has a real hard time putting in things other than natural causes. Of course, by definition, they do not exist in his philosophical system. So I think, ironically, a theist is a lot better situated to more objectively evaluate the evidence in this area than a non-theist. Yes? Uh-huh.
It's not surprising that both sides, evolutionists and Darwin's black box philosophies, would be surprised that light occurred 100,000 years after the Big Bang, whereas the first light-sensitive spot occurred billions of years later. In terms of your philosophy, would this not better support your theory than evolution, which is limited to evolution of man on Earth?
I'm afraid I didn't quite catch it.
Well, about 100,000 years after the Big Bang, the electrons were captured by nuclei,
Right.
and the first rays of light
Uh-huh.
came through. And many billions of years later, we talk about a light-sensitive spot. So would this not favor a philosophy based on, say, Darwin's black box philosophy, in which there is divine intervention, more so than evolution? Evolution, my point here is evolution is limited to man on Earth for the most part. And this goes back much further than that.
Yeah, well, no, I don't think a Darwinist would concede anything there. He would probably just say that when life was in the process of evolving, it took advantage of whatever was present in the environment, and light just happened to be plentiful, and so organisms that could detect it and use it had some sort of selective advantage. So I don't think they would be perturbed too much. And of course, they're not, because they know that the existence of light preceded the existence of light-sensitive spots on Earth. Yes?
You think you're quite right that any objection to design would be dependent on a philosophy of science, not science. True enough. What if a good philosophy of science? What if someone say, what we got here is Behe's black box, design. And then it looks like you're not going to be opening that box. And if you do open it, you're not going to be able to do it with anything like scientific means. They say, what are the origin and development of these designers? What's their internal structure like?
Mm-hmm.
And yeah, right now they're like Darwin's light-sensitive spot.
Well, that's a good point, and certainly people have made that objection. How can we investigate this designer? This is a bigger black box than Darwin's. And I'd say a couple things. First of all, we have to follow the evidence where it seems to point, even if the evidence seems to say that things were designed and that would point to difficult research problems. That's no reason for saying, well, then we will assume they were not designed and go off. It's like the drunk who was looking for his keys under the lamplight, not because he lost them there, because that's where the light was. Another point is that I don't think in the history of science you'll see that has not inhibited people from embracing a theory. And again, I'll use the Big Bang as an example. In the 1920s or so, when the redshift of the galaxies was noticed and the expansion of the universe was proposed, and that was the beginning of the thinking about the Big Bang, people noticed its theological implications. And they could have said, well, what good is this? Big Bang, we've never seen a Big Bang. How can we, what produced the Big Bang? What's the internal structure of the stuff that produced the Big Bang? What are the laws that produced it? We may never know. And we still may never know. But physics felt that it was entirely justified in proposing this theory because it fit the pattern of the data. And it's been very fruitful in the intervening years. And again, we may never know by scientific means who the intelligent designer was, how he worked, although I'm sure most people have their own candidates for who that was. But nonetheless, the data we have, I think, justify the conclusion of design. And perhaps if we follow the data will be as fruitful with that as physics was with the Big Bang Theory. Yes, ma'am.
We're going to have to make this the last question. For
Okay.
now.
As being both religious and a scientist, do you personally believe that evolution made everything, primarily that evolution made everything, or primarily that God made everything, or that maybe God started the ball rolling and let evolution take over?
Well, a couple of caveats is that, I'm a Christian. I believe that God's pretty much responsible for everything. And that whether it was used secondary means or more direct means, the distinctions, theologically probably don't matter a whole lot. But scientifically, it's a good question. Did God just have to make the first cell, or did he just have to make a flagellum and then natural selection could take over from there? I think that's an empirical question. You have to do the experiments to see, to answer that question. You can't just judge it, sitting in your armchair. Right now, if you look at the literature and you ask experimentally, what has natural selection been shown to be able to produce? It's surprisingly little. You can see, antibiotic resistance in bacteria, and you can show variation in various structures of organisms, but you do not see the ability to produce novel structures, even modestly novel structures that its proponents claim for it. So my feeling ahead of time is that natural selection explains a lot less than we typically give it credit for, and that explicit information is needed to explain perhaps the majority of features in life. Whether that holds out in the long run is again an experimental question, but that's my feeling right now.
So thank you very much, and we'll see you this evening.